Previously, you learned that you can solve linear systems graphically. Today, we're going to look at solving them algebraically, specifically using the substitution method. In another lesson, we will solve using elimination. Given two equations, you're going to solve one of the equations for one of its variables. And it's best to use the variable with a coefficient of 1. That way you can avoid fractions. Next, you're going to substitute the expression into the second equation. Now substitute the x or y value into one of the equations to determine the unknown value for the remaining variable. Finally, you're going to check your solution by subbing both values back into the second equation. If you get something like x equals 1, y equals -3, so the ordered pair would be 1, -3, that means there's going to be one solution. So basically one intersection. And you might remember that from the graphing that we did. If your variables cancel out and you get something like -7 equals 42, we know that this is not a true statement, so there's no solution. And if you remember, again, looking back at graphing, that indicates parallel lines. If your variables cancel and you end up getting something like -17 equals -17, that means that there's going to be infinite solutions, because the equations are actually graphs of the very same line, perhaps just in a different form. Now we'll try one together. We are going to solve the system using the substitution method, so that means we need to isolate a variable. And we said that when we have a coefficient of 1, this is a good variable to isolate. So we're going to subtract 3 from both sides, so I end up with x equals -3 plus 2y. So now substitute -3 plus 2y into my first equation. So everywhere we see an x, we're going to put -3 plus 2y. The reason we can do this is because it says x equals the -3 plus 2y. So they're representing the same values. So we're going to distribute. We end up getting -9 plus 6y minus 7y equals 14. We're going to bring down our -9, combine like terms, and now add 9 to both sides. Oops, forgot my negative here. So cancels, -y equals -5. Our final step is to divide both sides by a -1. Y equals 5. So now that y equals 5, we're going to sub in the value of 5 into the equation to determine the x value. So x equals -3 plus 2 times the y value of 5. X equals -3 plus 10. X equals 7. So my ordered pair, the solution will be 7, 5. Then your final step would be to put this solution back into the equations to make sure that they work in both equations.